Namaste to all my dear students. How are you? Today I am giving very interesting lecture about halogens, and that is very important for knowledge as well as examination viewpoints, and also asking what to say any competition examination, maybe medical, maybe engineering. Yes, so I will start halogen. Halogens. So when we talk about the halogens, it comes from hals, Latin word hals. Hals means sea salt producer element. Gens, Latin word, to produce, to generate. It means it is sea salt producer. For example, when we talk about sodium chloride, what we eat, sodium chloride, potassium iodide, magnesium bromide, calcium chloride, etc. These all are the example of what we see sea salt because they are found in sea. So that is about what is halogens. Halogens, hals, that come from the Latin word. It means sea salt producer element. Gens also come from the Latin word. It means to generate, or we can say produce. Yes, simple word. So for example, when we talk about the sodium chloride, potassium iodide, magnesium bromide, calcium chloride, these all compounds generally isolated from sea. So they are known as sea salt. Yeah. Now the characters. Characters of halogens. So two types, what we see, similar and gradation. Gradation means increasing or decreasing when you go from top to bottom or bottom to top. Yeah. So similar and what is gradation? Gradati, gradation. So first one we talk about the similar character of halogens. Yes. So first one is what's it? They have similar electronic configuration. You know about the electronic configuration. I have already give you the YouTube about the electronic configuration. So first when we talk about they have similar electronic configuration. Suppose when you talk about fluorine, its atomic number is 9. So what we have 2, 8 and what to say 2, 7. 2 and 7 fluorine, that is chlorine. So what we see 17, 2, 8, 7. Next one is bromine. What we have 35 atomic number, atomic 5. So what we have 2, 8, 2, 8, 18. 2, 8, 18, 7. Likewise, when you talk about the iodine, so what do you see? 53. 2, 8, 18, 18, 7. So in all cases, what do we see? What do you see? 7 valence electron, 7, 7, 7. So valence electron is what you see 7. So they are included in seventh group of the periodic table. Why? Because these all are the example of halogens. Fluorine, its atomic number is 9, chlorine 17, bromine 35, and iodine is 53. So I have in periodic table. So when you study what you see the difference between the fluorine, chlorine is 8, and what you see chlorine and bromine is 18. Bromine and iodine is 18 difference. Yes. So periodic table. So in all cases, what we see 7, 7, 7, 7. So valence electron is 7. So they are included in what you see 7th group A of the periodic table. Yeah, first character. Second, they are diatomic molecule. Yes. So diatomic means molecule contain 2 atoms, that is known as diatomic. Fluorine, chlorine, bromine, iodine, bromine. Yes, so all are the diatomic molecule. All are diatomic molecule. Yes, diatomic means if molecule contains 2 atoms, that is known as diatomic. Yes. Third character is they have similar general precipitation except fluorine. Fluorine does not follow this rule. So what we have? So general reaction. So what you see is general reaction is NaX plus manganese dioxide plus conc sulfuric acid. When heated, it is the sign of heating. So what we get? Sodium bisulfate, manganese sulfate, H2O plus what is H2. So that is sodium hydrogen sulfate. You can say bisulfate, you can say. So in this case, X maybe chlorine, maybe bromine, maybe iodine. Yes. Here X2 maybe chlorine, maybe bromine, maybe iodine. Yes. So we take very simple example. What to say, if you suppose sodium, you have to prepare what to say chlorine that treated with manganese dioxide plus conc sulfuric acid. When heated, what we have? NaHSO4 plus MnSO4 plus H2O plus Cl2. For chlorine. For bromine, what we have to take? Sodium bromide. For iodine, what we have to take? Sodium chloride. So when we balance 3 is what we get? It's that one. Yes. That is the third similar property. But we cannot prepare fluorine by this method because fluorine is also a strong oxidizing agent. So we cannot prepare by this method. Next, fourth one is they generally formed halides means X having negative charge, maybe chloride, maybe bromide, maybe iodide. Yes, what we say? Suppose any metal halides with metal, with metals. Yes, suppose we take any metal. So when sodium is treated with X2 maybe chlorine, maybe bromine, maybe iodine. So what we have? NaX, that is sodium halide. Sodium halide, where X maybe chloride halide, maybe chloride, maybe bromide, maybe iodide. Let's always keep in mind, never confusion with what you see. That is X2 means halogen. Yes. So I think you have clear. So they generally form what you see when we take very simple example like Ca plus Cl2. What you get? CaCl2. Yes. So that is calcium chloride. Yes. So you are clear what are the similar characters. These are the main similar character of what you see halogen. So what you see halogen elements, maybe fluorine, maybe chlorine, maybe bromine, maybe iodine. Halides, X, maybe chloride, maybe bromide, maybe iodide. What is it? Halogens. What do you see? Chlorine, bromine, iodine. Next, halogen acid. So what do you see? HCl, you know, that is very important acid. Hydrochloric acid, HBr, hydrobromic acid, HI, hydroiodic acid. Yes. So that is about the general knowledge about halogen. What are the halogens? What are the halides? What are the halogens? Halogen elements, that is maybe chlorine, bromine, iodine. Halides, maybe chloride, bromide, iodide. Halogens, maybe chlorine, bromine, iodine. Halogen acid, maybe hydrochloric acid, hydrobromic acid, maybe hydroiodic acid. Yes, that is the similar or general knowledge about the halogens. Yes. Next one is B. Gradation. Gradation properties of halogens. Gradation means we know first class, second class, third class. If you get what you say 60%, we get first class. Less than 60, what we get second class, third class, like this. Yes, that is grading. Grading means sometimes increases, sometimes increases. So first one is first correct, gradation properties. So what do you see? State of halogens. What do you say? Fluorine, chlorine. Fluorine is pale yellow gas. Chlorine is greenish yellow gas. bromine liquid. So what type reddish? This bromine liquid. Iodine deep violet. Violet means pH color, you can say. So what do you say? Solid. So what do you see? First two member F2 chlorine are what is a gas. Bromine is liquid and iodine is deep, what is a solid. Yes, first one. Second one is electronegativity properties of halogens. So what do you see in this case? So when you go from top to bottom in the same group, its electronegativity properties what's it, decreases. Look at over here, fluorine, chlorine, bromine, iodine. It has 4.0, it has 3.0, bromine has 2.8, iodine has 2.4. So what do you see? Its electronegativity, what you see, decreases when you go from top to bottom. So what you see? Sometimes ask you, tell the name of the element which have maximum electronegativity value. Fluorine has maximum electronegativity value. Yes. So second properties. Third one is what's oxidizing properties of halogens. Decreases when we go from top to bottom. Yes, it means always keep remember this trend. F2, what do you see, chlorine, then what do you see, bromine, then it is the order. It means fluorine has maximum, iodine has minimum. What's oxidizing properties? Yes, minimum. So when you talk very simple example like what you see, F2 plus H2S, hydrogen sulfide. So what you get, HF plus sulfur, deposition of sulfur over here. Chlorine when treated with H2S, what you get, HCl plus sulfur. Arrow indicating downward means deposition of sulfur. Likewise, when you bromine plus H2S, what you get, hydrogen bromide plus sulfur. Likewise, iodine plus H2S, what you get, HI plus sulfur. So what you see, decreases. How can you say the oxidizing properties of what you see, halogen decreases as you go from top to bottom? So what you see, we have to see what you see, product. So in this case, yield is maximum. Yield is maximum. But in this case, yield is minimum. Yes. So you have clear. So fluorine has maximum oxidizing properties, iodine has minimum. So how can you show? So this fluorine, in this case, the yield of the what you see sulfur is high. In this case, what you see the yield of what you see sulfur is very low, minimum we can say. Yes. Third one is oxidizing properties. Fourth one is electron affinity. Affinity of halogen. Somewhat difference over here. So what we had in this case, chlorine has maximum electron affinity, then fluorine, then bromine, then iodine. This is the order. This is the order. Yes. So always keep in mind. Chlorine has maximum electron affinity value. Yes. Next one is what to say reaction with hydrogen of halogens decreases when we go from top to bottom. So look at over here. So what to say, when fluorine is treated with hydrogen, even reaction what you see in dark condition. Yes. So what you say reaction is very fast, and what you get HCl. Yes. Likewise, chlorine when treated with hydrogen, what you see in presence of sunlight. No, chlorine is very sensitive in sunlight. So what we have 2 HCl. Likewise, when talk bromine and hydrogen, so when you simply heat, what we have hydrogen bromide. Likewise, iodine plus H2. In this case, we have to use heated platinum catalyst, otherwise no reaction. So what you get 2HI. So what you see decreases when you go from top to bottom. Yes. Or next one is what to say reaction with water decreases as go from top to bottom. Yes. So what to say H2O. So what you get HF plus O2 in dark also very fast. Cl2H2O. What you get HCl plus what to say O2 HBr. In this case, not heat, sunlight, HBr plus O2. But when we talk about the water, so in this case, no reaction, any condition. So what you see? Decreases. Yes. So fluorine has fast. Iodine, in this case, what you see? There is no reaction. So when you go from top to bottom, so what you get reactivity of what you see halogen with water decreases from fluorine to iodine. In iodine case, what is the no reaction in any condition? Yes, that is what the reaction with. Now the what to say. So we have talked already. In all generally case, what we see when you go decreases its properties when you go from top to bottom. But reaction of, better to say, reducing properties of halogen acid like HCl, HBr, HI, hydrochloric, hydrobromic, hydroiodic acid, what you see, increases when you go from top to bottom. So look at over here. So what do you see? HF plus Kong sulfuric acid. You know, Kong sulfuric acid is a strong oxidizing agent. That is oxidizing agent. You know, oxidant and oxidizing agent. So what do you see? No reaction, because both are oxidizing agent. Likewise, when HCl plus Kong sulfuric acid, when heated, no reaction. HCl is also oxidizing agent, there is no reaction. But when you talk about the hydrobromic acid, Kong sulfuric acid, when heated, so what we have? H2O plus SO2 plus Br2. So what the function of H2SO4? -1 to what you see? 0. So what you see? Increasement of the oxidation number from -1 to 0. Likewise, when we talk about the HI, when heated with Kong sulfuric acid, so what do you get? H2O, SO2 plus I2. So what do you see? -1, what do you see? 0. That is the oxidant, you know. So what do you see? Increases. It means HI has maximum reducing properties. HF has minimum. It has minimum reducing properties, but it has maximum reducing properties. Yes. Last one is melting point and boiling point of halogens increases when we go from top to bottom, like, you know, so what do you say? Fluorine, you know, gas, chlorine is gas, bromine is, both are gas, bromine is liquid, iodine is solid. So what happens? Solid has actually what you see is has maximum melting point and boiling point with respect to liquid and gas, you know. So these are the important gradation properties among halogens. I think you have clear the what is the similar and gradation properties of halogen. So generally asked in examination, also very useful for knowledge and examination view of point. Yes. So thank you very much for visiting this what is the interesting video, and I think you have already described it and conveyed to your students for knowledge. Yes. So have a nice day. Be bona fide in chemistry like Halogens. Thank you.